there's an outbreak of an infection caused by a new strain of a virus in CDX. The probability P of a randomly chosen person being infected 0.2. So find the probability that in the random sample of 12 people, at least 4 are infected. So very easy. So it means I see X will just take on the binomial distribution where the N is 12 and the probability of being infected is 0.2. Alright, so you want to find that at least 4 is going to be infected. Okay, so very quickly, the probability, let X, of course, let's define the event first. Let X be the number of people infected with the disease. Okay, then X will take on the binomial distribution of 12, 0.2. Okay, so the probability of X to be greater than or equals to 4, right, this will just be like 1 minus the probability of X less than or equals to 3. Okay, and with that, just use binomial CDF, use your GC, and you will get the answer to be binomial CDF using your GC, and this is what you get, and approximately the answer is just 0.205. Okay, at a certain time, the virus mutates and then the P increases to 0.6. Find the probability that in the random sample of 100 now, there are at least 60, but not more than 80 who are infected. There are at least 60, right? There are at least 60. So probably that X is at least 60, but not more than 80. So it's at most 80. Am I right? So not more than 80, but it still includes 80. Okay, so very quickly, if you let X to be the number of people infected with disease again, X will take on the binomial distribution now because there's 100 people and the probability is 0.6. Alright, so with this is just very quick, carefully remember how we go about doing this. This is less than 80 minus not 60 but 59. Alright, because we want to include 60, so we should minus 59. So this will just be use your GC. Answer will come out to be 226, and finally it's 0.543. Okay, next one, the virus that mutates to a much more deadly form. The value of P is now 0.97, and then in a random, find a probability in the random sample of 100, at most 5 are not infected. So if you want to see at most 5, this means that we're also saying that at most 5 are not infected. So it's like if we say we let Y be the number of people, so we think in complement, we can say let Y be the number of people not infected with the disease. Alright, so here Y will take on the binomial distribution of 100, and then you know that 0.97 is the probability of getting infected, so the probability here for Y will be 0.03, and we want at most 5, right? This is what I mean, less than or equals to 5. Alright, and with this, using a GC, binomial CDF, right, you will just get the answer to be 0.919. So you can also think in complement. You can say at most 5 at most 5 are not infected. You can also think about it as at least 5 are infected, right? So maybe if you think about using X, then you say binomial 100, maybe 0.97, and you try to find maybe probably of X. At most 5 not infected is the same as at least 95 are infected. But you're gonna get the same answer. Okay.